So, hello, welcome. I'm Professor Liles. You can address me as Professor Liles. And this is CS 612, Data Mining Exploration. Get out of here. There we go. And the objectives here, and because I'm a professor at an accredited university, I'm just going to read the slides. We're going to explore the facets of machine learning. We're going to have a data scientist checklist. We're going to also talk about the practical applications of converse inductive integrals in the context of epsilon. This is real exciting stuff here. There's some prerequisites for this class. Basic understanding of statistics. You have to know statistics to do machine learning and data mining. You need to know linear algebra. You need to know a little bit of calculus. And you also need to have the ability to embiggen factorials in a cromulent fashion. So let's start off with a review of stuff you should know. Anyone know what this is? And I feel bad because I gave this talk a little while ago. And let me actually preface this. This was actually supposed to be Gustin Prudner's spot. I work with Gustin at Thunderbolt Labs, and he got sick with some third world disease, and we thought it would be best that he just not show up. We like Gustin. We wish Gustin would be the best, and I'm stepping in just to help him out. Go to Thunderbolt Labs. So does anyone know what this is right here besides math? By the time I'm done with this talk, you will know what this is. Yeah, math sucks. So let's talk about something else. Let's talk about some background. This is an introduction to machine learning. Machine learning is one of those really overloaded topics that I prefer to not use that word. So let's not talk about an introduction to machine learning. Let's talk about an introduction to data mining, because you know what? Statisticians have been data mining for the past 40 years. This talk is depth versus breadth. I'm not going to go in deep. I'm just going to slide across the top. I think it's better for all of us if I do that. Let's talk about machine learning or data mining. What can we do with this kind of technology? Everyone in here has problems that can be solved with data mining. I was talking to a gentleman earlier from DigitalOcean, and he came up to me and he was thinking, oh yeah, machine learning. I want to be able to detect abuse. You can actually have applications of classification to detect abuse. What you can do is you can have your logs come through, and you can actually start classifying your logs as good traffic or bad traffic. You see this stuff all the time. Spam Assassin came out, I think, in the 90s. This is an application of machine learning. You have spam, you have ham. So these are the kind of problems you can have. And I've written things in the security context where we were detecting anomalies. And I didn't know it was machine learning at the time because, you know, I learned everything. I got an internet degree. That's about what I have. So I learned it all off of Wikipedia. I didn't know it was machine learning, but come to find out, these are kind of things that we're going to talk about machine learning. One thing I need to tell you about is I might use these words, supervised versus unsupervised in machine learning. This is very simple. You'll see people talk about that. This is an unsupervised algorithm. This is a supervised algorithm. This is very simple. In machine learning, you can train these models or your algorithms with data. They're supervised. Or you can have a model that can actually gain inference just by supplying the data. That's unsupervised. Simple, simple. I work at Thunderbolt Labs. They're pretty awesome. You guys should at least go to our website. Actually, yeah, go to our website because, yeah, our website's, I'm pretty proud of it because, let's see here. All right. Someone put my face on it. So, yeah, anything with my face on it has got to be awesome. I'm Bryan L on Twitter, and the standard disclaimer is I do not represent Thunderbolt Labs, except for I do. I do use vulgar words. I'm never misogynistic or anything like that, but I might offend you, so follow with me with, just be careful. And then Thunderbolt Labs, here at Thunderbolt Labs, follow us. We tweet there sometimes. Here's a really cool thing, and this is me getting on my soapbox and stepping out of machine learning for just a couple seconds. You see at the bottom, RubyConf website. We are actually sponsoring, as a gold sponsor, RubyConf this year, and I'll tell you the reason why. This is my 8th RubyConf. I am not an old-timer, which is crazy. I've been coming to RubyConf for 8 years, and I'm not an old-timer. Never once have I, as a black guy, felt intimidated by anyone in any talk at any time. So anyone saying that RubyConf isn't diverse is out of their mind. So off my soapbox, and let's move on. So let's talk about required knowledge for machine learning. There's a couple things you're going to need to know. You are going to have to know math. I presented that equation earlier, which was actually an equation for k-means clustering. It's actually really simple when I explain it to you. You will have to know math. You will have to know a little bit of calculus. You will have to know a little bit of algebra. You might have to dive into some statistics. You will need to know these things. But guess what? There's easy ways to learn this kind of stuff. You will have to read papers. And I'm not a fan of papers because I went to ClosureCon last year, and every talk was like, so I read this paper. Whoa. I mean, this is a good paper right here. This is a paper on transactional memory. This is STM. This is one of the tenets of Clojure. And it's actually pretty famous. It's actually pretty crafty, because look at it. Look at the authors. They're like, wow, we're not even going to put two EMLs on here. We're going to put them in little curly brackets. You will have to read papers. But you know what? There's nothing wrong. A little tech in your life never hurt anyone. You're going to have persistence. This is an interesting science. There are different facets of machine learning, and depending on who you talk to, if you talk to a statistician versus more of an applied mathematician, you're going to get different answers about what machine learning is. You're just going to be very persistent in the whole entire topic, because guess what? This is hard. So let's get started. And today I'm going to introduce three topics: regression, classification, and clustering. These are three of the bigger tenets of machine learning, and you can solve all the problems. I'm here to solve all your problems today. So let's talk about regression. Yes. So does anyone know what regression is besides the black guy in the back? Anyone else? Anyone else? You guys know what regression is? Regression is a weird word to me. Because you know what? I think I take the base of this word, regress. And regressions really are not regressing. Regressions are really just trying to figure out, you're trying to predict the value of something given some data. A good example of a regression would be you have a list of data of housing prices of houses being sold, and you know that the house for $100,000 had 1,000 square feet and 2 bedrooms, and the house that sold for $150,000 had 1,500 feet and 3 bedrooms. And you have many, many samples of this. So what you can actually do is you can take this data and you can actually somewhat accurately predict prices based on common criteria. But we're going to focus on linear regression. And what linear regression is basically we're just going to have it move linearly. So let's talk about this. Does anyone know what that at the top is, what that equation is at the top? It's the slope of a line, yes. And actually, here's a problem that I have, and I have a huge problem with mathematics in general. When you were taught this in middle school, I guess you learn line slope formula in middle school, you were not taught anything that looks like this. You were taught something that looks more like y equals mx plus b, and they have y equals alpha plus beta x. Come on. This is the problem I have with mathematics. Depending on the branch of mathematics you're in, they will actually use different symbols for the same thing. Talk about persistence. You just got to bear with these guys. And for doing regressions, all you're going to do is solve this equation. Come on, this is simple. You're minimizing the function q of a of b, or alpha beta, where the function q, alpha beta, equals e squiggly e with another kind of e with a hat. It has a hat. Why does it have a hat? All right, this is funny. Really, all you're trying to do is this. So talk about the line slope formula. You have y equals mx plus b, and then I just go through the permutations to get to y equals beta of chi plus alpha. Really, all you're doing is you're drawing a line. And what you're going to do in this line, and I'll show you in a second, first you're going to take this data. And actually, this data right here is, I just went for linear, I looked on the internet, I used Google for linear regression data sets. And I come across this cool one of the size of brain, the body weight versus the size of a brain. And I plot it, because that's what you do. You plot stuff. I just use GNU plot here. This is not Ruby. Sorry, there's no Ruby yet in this talk. But I just plotted this data. And this is a very interesting data set because it says that it was a real data set, but I don't know. Because if you look over here, I mean, I got a big brain. I'm not gonna lie. I'm a smart dude. But jeez, I want to meet this person right here. And in linear regression, what all you're trying to do is you're trying to draw a line that actually goes through the middle of all this data. And he's like, well, we can infer that pretty easily as humans because we're linear regression monsters. But how do you do that mathematically or algorithmically? So what you're trying to do is you're trying to calculate something called the error. And what that is the error is the distance between a point and a line. And remember before when it was that minimizing function? You're just trying to find a line that minimizes the distance between this and this for all the points on here. This is not the right answer. And just to simplify that a little bit more, this is all you're doing. You're just basically trying to find a line that is between the middle of all those points. And we can do it with math. But better yet, we can do it with Ruby. And I put code slides in so I could actually remember to go to my code. So let me hide this bad boy. And there's that pretty guy again.
Same jacket.
You know what? I like this jacket. There we go. We'll just mirror the displays. This is getting to be a little difficult for me to look backwards. So you know what happens is I had never given this talk with Mavericks. And Mavericks will get you. It's nice, but it'll get you. So we're talking about regression. So what I've done here is I provided some examples, and let's look at the Ruby code. No, actually, let's look at the GNU plot code first, because this is GNU plot conf, right? Let's look at some GNU plot. So I'm using them this week. If you know me, I actually, I use a lot of editors. And I know this is a conference talk, and there's sometimes some like clipping on the sides. So what I'm going to do is move this slightly over so we can see everything. So let's look at this regression. So what it is I've written some GNU plot code, and really all I'm doing is making a ping called brain.ping, and I'm just setting the X labels and the Y labels, and I'm setting a grid, and I'm plotting the second and third columns of this brain.csv. Simple, simple. So when I run this GNU plot, and this is how you run GNU plot stuff. You don't even need to just pipe that crap in. And I did it, and it ran really fast because it's not Ruby. I'm just kidding. And I plotted. That's how I plotted that. So let's go one step further. If I want to actually, let's see if we can do this in Ruby. So if we look in this regression.rb, there we go. This is actually the code for doing regressions in Ruby. And what you'll notice here is that we have this y-intercept and we have this slope, the mx and the b part. And we're just calculating those. I actually was going to write this code, but I just searched for simple linear regression in Ruby, and there was a gist for it. So guess what? rwald, here's your credit. Why write code that's already been written? So all it does the same thing. And at the end, I like to call this train Ruby, because you'll notice that I usually start in classes and I end in just a mess. And the reason why is because I wrote this on a train, and I was like typing, and then I start looking out the window and got distracted. Yeah.
This is your Ruby on Rails then.
Yeah, this is my, yeah. So this file's not too bad. There's only like 10 lines at the bottom that are kind of crazy. So we'll run this. Regression1.rb. And really what we're looking for are if you want to plot a line, you just need the slope and the y-intercept. So we have this number, 6.64 and 6.67. Can someone remember those numbers for me, please? Because I'm going to ask for them in a second. And then what we'll do is, because the last thing we'll do is we'll actually look in this second regression text file that I have here. This is more GNU plot code. And what it's actually doing is GNU plot has linear regression built in. So we'll just use theirs. And all I'm doing is, instead of writing tests, I'm actually just I'm using GNU plot to actually figure out or tell me if I have the right answer. So if we look at the bottom of this file, we have an M and a B right here. And GNU plot does a whole bunch of other crazy things too. But we actually told it to fit the data. And you notice the number here is 6.62 and 6.88. Close to our numbers. I mean, our numbers could have been better. These numbers are actually a lot better because GNU plot actually goes through and figures out, first, if the data is linear, and also it gives you error numbers. So this is actually the real answer, but our Ruby code is pretty close. And that brings me to a little point here. You will not do a lot of machine learning in Ruby. But because Ruby is so approachable and so easy to use, Ruby is a great learning language to learn how to do machine learning before you have to go apply it somewhere later. So just to show you one more thing, we'll plot the output of our we'll plot the outputs of our files here, and okay, and we'll open brain regression, and that's our file. This is from GNU plot, and we'll open brain regression Ruby, and there you go. They look similar. Actually, we'll put them right next to each other so you can inspect for yourself. Simple linear regression in Ruby. This code will be on GitHub, or actually is on GitHub. You probably can find it now if you know I'm Bryan L. But you'll notice that these are the same, and one's with Ruby and one's with GNU plot. And this is how simply. And you'll notice if we go back to our file here, regression 1.ruby. It's not many lines. Actually, it's like 47 lines. Let's say it's 42 lines. It's 42 lines. So that's regression. And what I'm basically showing you is that it's easy in Ruby to plot lines. And because you can plot lines, you can do simple linear regression. Let's talk about classification next. And before we talk about classification, I want to show you something here. I'll go to my web browser. That guy keeps on coming back. I want to show you something. There we go, make it a little bit smaller. My computer's pretty smart. I wrote this Sinatra app called The Number Game. And I'll reload it a couple times, and so you can see what's going on. So here's once. Here's again. And so what's happening here is there's a data set called the MNIST data set, and all it is a collection of 60,000 handwritten numbers. And what I did is I wrote a simple app to actually go through and recognize numbers. Simple application of machine learning. This is what you call classification. We are classifying these pixels as a number. And you notice that for the most part, I believe that this classifier is 65%, maybe 75% correct. I don't really remember. So how do we do stuff like this? Well, first of all, with classification, let's go back to my slides. How do we classify? Well, with classification is actually really simple. We're basically doing the same thing we're doing in regression, but we have way more dimensions. So in that other file here, we have an image, and this image I do know is 28 by 28. And I gave this talk before, and I asked somebody, does anyone know what 28 by 28 is, times 28 times 28? When I was in Boston, someone yelled the answer out before I finished typing it. He was my special mind. But this particular file has 784 pixels. So that we have 784 features that we can classify this document against. And really what we're doing is we're, in memory, just drawing lines and trying to find out, we're just predicting, basically, what our image is. So without further ado, this is Ruby Conf. Let's see some code. Let's see, classification. So what I have here, I'm actually going to run, I wrote this classifier. I'll run it real quick, and then I'll show you what's in there. So what it's doing is I have 60,000 images that are 28 by 28, and I have 60,000 labels. And that's the reason I know that I'm right, or that's what I know what it is, because the data is labeled. What I'm doing right now is I'm running a trainer on it. And in this case, I'm using something called support vector machines. I find it's easier to use it and then tell you what it is. So really what I'm doing here is I'm classifying this data using a support vector machine. And then I'm predicting the data. So I have a $60,000 count training set, because this is supervised learning. And I have a 10,000 count test set. And what it's doing now is it's actually going through and seeing how accurate the classifier was. And what we find here is that I'm only about 65% accurate. And the reason why is because I'd actually have to go through, if I actually train all 60,000 of those things, in Ruby, because of my global interpreter lock, I only have one core of usage. So I actually tried to do it. I stopped at 3 days, because it was just so slow, because it was just using one core. Really, but what it's doing is actually, is going through and it's saying, this is an 8. Computer says, okay, I know that. This is a 4. Oh, that's a nice 4. I know that. This is a 4. And then they're all looking different. And then when I go back through with the test set, all I'm doing is saying, well, I think this is, and I think this is. So let's look at some more train Ruby. So this is, and I'll show you a good example of this. I was really into this code when I was started, and I'll just go through and I'll talk about it. I have a data set, and then I have this loader which actually just loads the data from the files. The files, it's a binary format, and it's all gzip, so ignore all this. And then what I do is I load the labels, and the labels are along with the file, and it basically says this blob of data is a 4, this blob of data is a 5. And then I start looking out the window on the train. So really what I've done here is, so the line at the top is I'm basically setting the timer, and I'm loading the data, and then I'm actually going through, and I'm using something called libsvm, which I'll talk about in a second, and I'm classifying all the data. This is a really important lesson. If anyone in here is writing machine learning algorithms, you don't belong here. You belong doing something very important. In machine learning, you will stand on the back of giants. You will not write machine learning code. You will use things like Shark and Spark, or you will use Mahout, or you will use libsvm, or you will use AI4R, but you will not write this code. And what I'm doing today is I'm trying to introduce that to you so that you can see how easy it is to write something like this. This took me about 20 minutes to write. Really, it's just a Sinatra app. It's not even a Rails app. It's a Sinatra app, and it just throws an image up, and that's it. I'm pretty proud of this. I'm sorry. So, moving on. So we talked about what we did here is linear classification, and we use a support vector machine, and there was code. I jumped ahead. And there's also something called classification with the decision tree. And I was going to talk about this, but I was looking through RubyConf talks last year. I actually don't go to the talks at RubyConf for some reason. But I actually watched this whole talk. This guy, Chris Nelson, did a talk in Denver at the same conference last year. And this is actually a pretty good talk on decision trees. He goes for 40 minutes on one topic. And it's pretty good. So basically, decision trees are this. You basically learn how to divide your data into if-else clauses. And you do it as a tree, and you just go down until you get more and more specific. You'll find that there's actually software out there that builds huge nested trees, and that's how they're doing their classifications. So here, let's talk about clustering. What can we use clustering for? Well, we can use it to group documents, group-like documents. We can use it to detect plagiarism. So this is actually a new part of the talk, and I wanted to do some live coding. So what I'm going to do here is go backwards in my prize session. And there's something called Jacquard's constant, or coefficient. And what it does is it allows you to take a set of data and classify it again, or compare it against another set of data. And basically what we can do with this is we can actually build a tool that can detect plagiarism. And let me show you how easy this is. So I required Jacquard. And what I went and did on the internet is I went and searched for some text. So what I'm going to do here is I'm going to cut and paste this text off this web page, plagiarize it, and I'm going to put it in a variable. And then what I'm going to do is make a variable called achunked. This is another little quibble I have about Ruby. So you do a whole bunch of underscored case. You can't tell me that doesn't look better than this. I'm sorry. I like this better. Maybe I must have been in Java and Scala too much. But so what we're going to do is we're going to chunk up that A. So we can do A dot split, and we can do like this. This is what we'll call poor man's NLP. And now we have an array with our data in it. And what we'll do now is we'll go down here in another example, and we'll copy. This is supposedly plagiarized text. So we'll just go B equals this. I probably could have wrote a function to do this, but I did not. And this is live. We're on TV here, so we'll do it all at one time. So now we have this. And now for C, I'm just going to say, that's my new paper. So we have A, B, C, and we got to chunk up C too into So now what we're going to do is, I have to go back here. There we go. Is we're going to find which two papers match each other. Go. This is live coding. I'm not cheating this time. Thank you. Now, see, this is a group effort. There we go. All right. So what it did is it actually returned the whole entire array. But if I go through this code, and because I'm in Pry, you'll notice that it returns two arrays. And the two arrays are is the original copy and the plagiarized copy. Notice that my copy, it's saying that these two documents are similar. And what we can also do here, and I'll move this to the top in a second. Yes, sir. Oh, sorry about that. So we'll do the coefficients, and this is Jacquard's coefficient. We'll generate coefficients for. So notice these numbers are 0.015, and if we go and see, you notice that this number is a lot lower, 0.01. What we can do with Jacquard's coefficient is we can actually compare documents based on how similar these numbers are. Once again, simple plagiarism detection. We call it classification in machine learning. Yes, sir?
What does Jacquard's coefficient look like?
Man, I don't know. Actually, I do know, but I'm not going to tell you. Go look on Wikipedia. But no, we can talk about it in a second. I mean, after the talk. So the next thing is k-means clustering. And this is a fancy topic. That formula that I showed you earlier was k-means clustering. And what you can use with k-means clustering is something neat. So imagine that you have a scatter plot of data. And I have a scatter plot of data. Uh-oh. Uh-oh. I'm having technical difficulties. I mean, like, seriously. Keynote 13 crashed on me. All right, so we'll reload Keynote. So imagine we have some dots. And pretend these dots right here are star-filled maps. So pictures, two-dimensional pictures of distant galaxies. And we want to take those galaxies and we want to cluster them into groups because we're going to say that these stars that are in a close group are our galaxy. So this is not Ruby. This is actually JavaScript. But so let me show you this. Let me show you what the computer can do. So I'm going to reload this page, and you're going to notice that the colors are a little bit off. But just wait a second here. There we go. Did you see that? So what I've done here, you're going to be like, Bryan, what'd you do? So what I've done here is, you see these bigger dots? These bigger dots are called centroids in k-means clustering. And what I'm doing is I put them on the screen randomly. And what I've done is I color the little dots based on the closest big dot. And then what I do is I move the big dot to the center of all the similar colored dots. And then I do it again. And then I do it again. And I do it again until it stops moving. And then when it stops moving, I've detected things that are similar. So you'll notice that down here in the bottom corner here that we can detect with our eyes that this is a different group. And we can detect with our eyes that this is a different group. With k-means clustering, usually what they'll do is they'll run it hundreds, if not thousands of times, and they'll actually generate a good sample here. Yep. We'll generate a good sample here, and what we'll be able to do is use averages over the time to actually determine what the probability of a group of a little dot being in a group of a big dot. So let's see something here. So let's go up, and we're talking about clustering, and let's just look at k-means. This app is actually this is actually a D3 app. I'm not going to talk about the code. I just want to show you how much code it is. And this is why we use Ruby, because come on. Yep. Come on. Yep. Come on. Yep. Wait, we're almost there. Wait. Yep. Okay, we're there. So the reason I show that is because this brings me into a new topic. And like I said, I'm not, oh my gosh, it did crash. I'm not here to show you how to do machine learning. I'm trying to show you what machine learning is and practical applications of machine learning. So I have 9 minutes and 44 seconds. And let's go to here. So let's talk about doing machine learning in Ruby. God. There. There is a package out there called AI4R. You can gem install AI4R right now. It implements a lot of the things that I was talking about earlier. Here's a picture of their web page. There's a project called JRuby out there, and it is a lot of scientific stuff, so a lot of linear algebra things that you would need for machine learning. But the problem with JRuby is that it's more like a science experiment, and it doesn't have the funding it needs to be complete. So people are using it, but there's much better things out there. You can use JRuby and Mahout. Apache Mahout is actually one of the de facto machine learning packages out there, but it's written in Java on the JVM. If you use JRuby, you can actually get pretty easy access to it. And because it's so popular, someone wrote a JRuby Mahout plugin, but you can tell that they were really interested in it because the last time they looked at it was 11 months ago. So what I'm going to do now is I'm going to rail on Ruby for just a second. I love Ruby. I write Ruby every day in some fashion or another, and I use it for a lot. But Ruby is not good for machine learning because Ruby is not fast when it comes to math. The JRuby project and some of the things inside of there are trying to fix it. But the problem is, even getting to that stage of installing this stuff is hard. To install JRuby, you need to install something called Atlas, which is damn near impossible if you have a Mac. We also don't have easy plotting in Ruby. You notice that I use GNU-plot and D3 for all my plotting examples. There is a Ruby GNU-plot gem out there, and you can use it. But Ruby does not have great native plotting stuff like matplotlib and Python. There is no integrated environment. Ruby has IRB, and I was using Pry earlier, but there's not like a MATLAB or Mathematica or an IPython for Ruby. We really do need this. And also, I want to be able to do what I need to do. As a scientist, I want to be like a scientist. As a scientist, I don't want to be a programmer. Ruby still does not have the maturity and the idioms to allow scientists to be scientists. This is why all the scientists either use Matplot, or they either use MATLAB, or they use Python, because it allows them to still be a scientist while letting them get stuff done. So I don't want to rail on Ruby. What do you want to do if you want to learn more? Because really, I cannot give you guys an advanced talk. I could actually talk on one subject, like classifiers, for this whole entire time. But I want you to learn linear algebra. And you know, I've probably said this 3 times already. You need to learn linear algebra. It's not hard. There's a Coursera class on it. It's not hard. You need to learn calculus. You notice I had a minimizing function earlier. You need to learn how to minimize. You need to know some kind of statistics. My friend Randall in the back will tell you that you need to know statistics just in general, but you need to learn some statistics. You at least need to know how mean, min, max work, how standard deviation works, and a few things around there. There's a Coursera class on machine learning from the guy at Stanford. I would say watch it. It's kind of dry, but at least it'll give you some of the things you need to know. My partner in the back, Randall, has actually written a great blog post on getting into machine learning that he's going to post. He has to now because I just said it in public. And another thing you want to do is use Wikipedia. I'll tell you what, I got to show you this. I got 5 minutes. I'm going to show you this. So Wikipedia is amazing. Anything you want to know, some smart dude or lady has written it on Wikipedia. So if you want to look up support vector machine. Yes. There it is. Some nice person has written how it works. If you want to look up k-means clustering, some smart person has written how it all works. Wikipedia is better than any textbook. I'm not lying. You also need to read this book by Peter Flack. There's a lot of books on machine learning out there, and this one's hard to buy on Amazon, and it might be like, I don't know how much it is, maybe it's 50, 60 bucks. There's not many books that I will say are great. The first chapter of this book is probably the best reference on machine learning out there. And I'll wait for a second so you guys can take this in. This first chapter of this book by Peter Flack is the best thing I've seen on machine learning. But if you want to get serious, I want you to find a data set, find another language, unfortunately. If you're really serious about this, you're not going to be doing it in Ruby. Then you'll want to do the dot, dot, dot dance, and then maybe you'll profit. But I'll tell you what, we haven't even scratched the surface. Scikit, scikit-learn, which is in Python land, actually has this huge chart of all the things you can do in machine learning. We only talked about 3 things on this list. And look at all these little circles and lines. There's so much more you can talk about in machine learning. I want you to go look at Big ML. It's actually a great machine learning platform, and it's a lot of tutorials on there. Undundus, this is a website. Their blog has interesting every once in a while. Kaggle has contests, data sets, and an interesting blog. You might want to go look in Python land. NumPy, SciPy, scikit-learn, and Matplotlib are godsends in IPython. Look at Apache Mahout. And there's a newcomer on the block. I'm just throwing things out there for future reference. Shark with Spark. Prediction.io, this is the newcomer. It does predictions tools. It's actually pretty neat. I got a data set in there, and I was not unimpressed. But the cool thing about it is that it's only building on technologies we already have. I mean, it's not a new thing. It is using Hadoop. It is using Mahout. Here's some slides. Here's where the code for this talk is. If you're really into that kind of stuff, no one really looks at this stuff, so I'll put it up there for posterity. But I want to show you something with the last couple minutes I have here. So this is what Ruby needs. If I were to walk around to everyone and say, you know what, I can tell you what Ruby needs. Ruby needs IPython. Has anyone here seen IPython? All right, I'm about to blow your guys' minds. So IPython is basically pry on a web page. And because I'm so awesome, I'm just going to type in some Python. I'm just kidding. I'm not going to do that. So 1 + 1 = 2. You're actually writing Python in your web browser here. This is a transformational tool. We could actually do this better. And I'm not saying that we should just go steal this, but you know what? Rat got us really, really far. You guys know where rat came from, right? From Python. Another thing I want to look at, and this will be the last thing, is, oh, actually, you know what? I'm done. Thank you.